very early there, right?
It is very early, yes.
Yeah. 13 and a half hours, right? Oh, now
Yeah.
12 and a half hours, I guess.
Yeah, because we went through our time zone, daylight savings
Yeah,
time.
daylight savings. Yeah. I always keep up daylight savings because I watch a lot of football, soccer.
Okay.
So I
Okay.
have to continuously keep in mind the timings so that I don't miss a game.
You don't want to be an hour late, you miss all the action.
Yeah, exactly. How is the COVID situation okay now in California or?
Yeah, California's in pretty good shape. I
Yeah,
see India's been in really tough shape.
we are doing very bad. We need to we need to speed up the vaccination, otherwise it's going to be really tough for us.
Yeah, we've California has done a great job. A few states have done a really good job because we're still wearing masks, right? We
Yeah,
still, even though we've got vaccinated, I'm vaccinated, I still wear a mask.
yeah, yeah.
And California's been pretty strong about that, but some of the states, Florida, Michigan, Texas, they've not really obeyed the rules very well, and they're not doing as well.
I can imagine.
And so wearing masks, keep wearing a mask.
Yeah.
Practice social distancing.
That is true. My father will get the second dose tomorrow. So.
Oh, good. Have you been vaccinated yet?
So they are going to start for below the age of 45 from May 1. So I tried to register today, but the registrations have also not opened. But soon I will make sure I'll also get vaccinated as soon as possible.
Good. That's smart.
Okay. I think we will start in a few seconds. People will start joining now soon because it is 8 p.m. Indian time. We'll just wait for a few seconds and start.
So what time is it there?
It's 8 p.m.
Wow, late, really late.
Yes. Actually, the California becomes very distant because like that is 3.5 hours more than New York. Usually Eastern time, it's much more like feasible in terms of
much more reasonable.
Yeah. Planning timings and all that. Okay, I think we can start. So welcome back, everyone. I hope you have had an amazing day. We have had 14 sessions and we are on to our last but not the least session of the day. For this talk, we have with us Bill Schmarzo, an author, professor, innovator, and a data science consultant now. Bill is the former Chief Innovation Officer at Hitachi Vantara, where he was responsible for driving Hitachi Vantara's data science and co-creation efforts. He was selected for Hitachi Limited's 2020 Solution Innovation Awards for his groundbreaking work in data science and automated machine learning. Bill also has served as CTO at Dell EMC, where he formulated the company's big data practice strategy, identified target markets, developed solution frameworks, and led analytics client engagements. Today, he will be speaking with us on the topic of data science 2.0, from outputs to outcomes. Bill will explain how data science should progress in order to get the maximum economic value of data and analytics. He will elaborate on how to move from just providing analytics outputs to delivering material and meaningful businesses and operational outcomes. Attendees, please feel free to ask questions to Bill. You can pop them into the Q&A tab as well as the chat box. Bill, you can take them during the session, or you can dedicate the last 5 minutes of the session for the quick Q&As. So
I'll dedicate the last 5 minutes. Easier that way.
Awesome. So I'll stop sharing my screen, and the screen is all yours, Bill.
All right, let me figure out how I share. Can you see my screen?
Yes.
All right, great. So let me jump right in. And good evening. I know it's quite late there in India. It's actually quite early here in California. And what I want to talk about is that we, as data scientists, are going through a critical evolutionary point, a very natural maturation point. And what I mean by this is that what is happening is data science is moving away from being the practice of a high priesthood of specialists who understand tools and whose competencies and value add is understanding of things like TensorFlow and Python and SQL. We're seeing data science move from a set of competencies and capabilities evolving into a profession that has to mature in how it thinks about how it provides value to organizations. And that really is around transitioning from focusing on developing and delivering technical and analytic outputs to how do we leverage the key aspects of data science to start delivering business outcomes. And we're being driven into this conversation because of this very simple but powerful phrase, data is the new oil. What does that phrase really mean? Now, data is not actually oil. You're not going to burn it to run your car or heat your home. But what this phrase importantly says is that in the same way that oil was the fuel that drove the economic growth in the 20th century, data will be the catalyst for driving the economic growth in the 21st century. That data is a source of economic value. And if we believe that, and more organizations are believing that, and we're starting to see results of organizations who are very data centric and how their market caps are starting to increase so dramatically, that if you believe this, and probably the single most important question that an organization needs to ask itself is how effective are we at leveraging data and analytics to power our business models? Notice this question is about business models. It's about how effective we are. And so what we did in order to help organizations understand what does good look like, where do you sit with respect to how effective are you and how good could you become, we created what we call the Big Data Business Model Maturity Index. And the most important words in this slide is the word business model. This is not how effective you are at leveraging SQL or Python or Jupyter Notebooks or TensorFlow or Spark or whatever else is out there. No, it's not about how effective you are at using technology. It's how effective you are at powering the business models. It's not a maturity of your effectiveness of using the tools, it's your effectiveness in using the tools to drive business value. And so if we believe this, if we believe as an organization that we have a chance to take our business organization from using data to monitor the business, to predicting, to prescribing, to monetizing, to transformation, we have a vehicle now against which we can measure ourselves and a roadmap for how we get there. But the key is, how do we make that first jump? How do we get organizations going? How do we, as a profession, as data science as a profession, how do we provide value? And I'm going to argue that the starting point for that is I'm going to call the value engineering framework. And the value engineering framework starts by understanding how your customers, how your organization makes money. What is a business trying to accomplish over the next 12 to 18 months? Let's figure out some organizations around customer attrition. It's around customer acquisition. It's about reducing unplanned operational downtime. It's about reducing hospital-acquired infections. It's about reducing readmissions, right? It's about improving freshman retention in universities. And so organizations have business initiatives. I'm going to show you an example later on. The key for us is to focus on that. That's the starting point for our conversation. Understanding what the company or the organization is trying to accomplish from a business and organizational perspective. Then we want to do is we want to go through a process identifying the stakeholders who are impacted by that. Then we want to identify the decisions that those stakeholders are trying to make to support their business initiative. It is these decisions, it is the linchpin that drives the linkage between the business stakeholders who understand already the decisions they're trying to make because they're making them today, and the data science team who can use data and analytics not to change the decisions, but to change the answers to those decisions. Let me be really clear about this. Every business stakeholder I have ever talked to knows what decisions they're trying to make each day. For the most part, it hasn't changed in years, decades, maybe even generations. The decisions haven't changed. What has changed are the answers. Because of the granularity of the data and these advanced analytic tools we have, we can now get much more granular, well-informed, actionable decisions to support we can drive much more actionable decisions that support the business initiative. Once you understand the decisions, everything else falls out. What data do I need? What analytics do I need to build? What's my architecture? What technologies? Everything else falls out. But we have to start with a source of value as created, and that's a business initiative. And in order for us to have those kind of conversations, we need to first and foremost realize that data is an economic asset. Data is an economic asset. It's not a technology byproduct. It's not the exhaust of the business. It is the fuel, the catalyst that's going to drive the economic growth in the 21st century. So we need to think about data as an economic asset, and there's some certain characteristics. Very importantly, data as an economic asset never depletes, never wears out, and can be used across an unlimited number of use cases at zero marginal cost. Think about the power of that. There is no other asset that an organization owns that can do that. And that's why we want to think about this from an economics perspective, because economics is a value in use asset valuation methodology. It is the value of data is measured in how you use it to create new sources of financial, customer, product, operational, environmental, society value. Economics is a value created by use, right? And if we start thinking about data as an economic asset, then we can start applying some very basic and powerful economic concepts like the economic multiplier effect. Let me walk you through an example of how the economic multiplier effect works and why it's so powerful for data from a data perspective. Let's say we have a data set, customer point of sales data. What we want to do is we want to go through a use case by use case approach to basically build out the value of that particular data set. So that data set, if it's curated, fully cleaned and aligned and normalized and standardized and all those other important things that makes data curated, then the sales organization can use that data to improve promotional effectiveness. Let's say they can improve promotional effectiveness by 2.5%. I'm not sure what that 2.5% is worth. Maybe it's $100,000, maybe it's $100 million. Depends on the organization. But I can use the data to drive new sources of value. That's the value in use concept. But wait, there's more, right? Marketing can use the same data set to improve customer acquisition, which has some financial economic value. Call center can use it around customer retention, or product development can do it around new product introductions. What is happening here is we can see very easily, this is very normal and natural, that we can reuse a data set over and over again. Each time it's used for each use case drives more value. And we get it at near zero marginal cost. Again, there's no asset that looks like this. And so in order to us to fully exploit the economic value of data, we have to associate data and the analytics with the use cases we're going to go after. We're going to take a use case by use case approach, not only to solve and deliver value to the organization, but as we go use case by use case, we're going to build out our data assets and our analytic assets. We're going to build them out incrementally as the organization needs them and as ROI dictates we should do it. It's not a technology-driven approach. It's an ROI-driven approach. And I love this quote. You cannot fully assess the value of your data in isolation of the business. That's the key point of this. We can't think about the value of our data without thinking about how that data is being used to create value as part of the business. Let's go one step further. Now that we're thinking about data as an economic asset, let's introduce some concepts here about how data as an economic asset can transform an organization's value curve. I'm going to introduce a concept called Nano Economics. This is something I've been working on for the last couple of months. And Nano Economics is the economic theory of individual entity predicted propensities. Whether it's a human, a doctor, a nurse, a technician, a teacher, economists, whatever it might be, they have predicted propensities. And we can use those predicted propensities to make much more granular, informed decisions about how we help them be successful. And it's also true, not just for humans, but also for machines and devices, right? We have these predicted propensities that each machine has. When something's going to wear out, what's going to wear out, when's it going to wear out, why is it going to wear out, right? We can create these very detailed profiles. We can leverage analytic, this nano economics, this economic theory of individual predicted propensities, and we can store them in analytic profiles. Now, some people call these asset models, some call them digital twins. when you're taking my class and reading my book, they're called analytic profiles. And what we're doing is for each of these entities, again, whether they're human or device entities, we are capturing, codifying their predicted propensities so that we can use this information to better serve that person, to better support our use cases. So this example is an analytic profile for Bill Schmarzow's healthcare, right? It has all kinds of score regarding my exercise, diet, wellness, et cetera. And then it also has scores regarding my likelihood to catch cancer or to have a heart attack or to die from COVID, right? So we can build these profiles. And what this allows us to do when we embrace the power of nano economics and create these very detailed scores and store them in analytic profiles, it allows us to transform the economic value curve. Now, what's an economic value curve? An economic value curve measures the relationship between an independent variable, a dependent variable, and a series of independent variables to drive or achieve a particular outcome. For example, let's say I'm a large industrial organization and I want to improve my operational uptime, right? If my factory is down, I'm not making any money, right? So I want to put in place, sorry, I'm getting a glare here. Hopefully this is better. Right. So I want to improve, I want to do more maintenance so that I can try to improve my uptime, right? More maintenance means that the factory is not down as often. But what happens when you have an economic value curve is that unfortunately the law of diminishing returns kicks in. That at some point in time, the more money you're spending on maintenance on these independent variables, the less outcomes you're going to get. Again, marginal propensity shrinks and the law of diminishing returns kicks in. And we can see that we spend more and more on maintenance and get less and less back for it. So how do we change this? How do we move away from generalized maintenance decisions, trying to improve uptime that hits the law of diminishing returns? What we can do is we can leverage nano economics to transform the economic value curve using very precision actions, well-informed at the individual entity level. We can use that to basically transform the economic value curve so we can actually do more with less. We can spend less on maintenance and get an improvement in uptime because we're much more focused on what we're doing the maintenance on, when we're doing it, who's doing the work, what are the consumables, what are the tools I need to help do that, what are the parts, right? Think about all the decisions that need to be made around trying to address an uptime, to do predictive maintenance. We can become very granular. And this has the benefit then of, for example, if we can do this in healthcare, if we can apply these analytic profiles around healthcare, like the one I showed you earlier, we can become much more granular in the decisions we make and impact the economic value curve. Now, this is a real chart here. Look at the economic value curve for the US spend on healthcare, right? The US is spending more and more money on healthcare, and it's reached the point of law of diminishing returns. The more it spends, the less it's getting. There's other countries who are doing much better. If you can see here, Japan does really well, Germany's doing well. I'm not sure what's going on in Switzerland, but you can see what happens here is that if we had these analytic profiles, if we leverage these concepts of nano economics, we could create precision medicine. We could create personalized welfare. We could do predicted world health and smart hospitals and intelligent applications. We could become very informed, because here's the really key point here. When you make decisions based on averages, at best, you're going to get average results. We need to move away from making decisions based on averages and start making decisions based on the individual's predicted propensities. Nano economics. All right. If we are going to transform data science into a profession, there's other skills that we need to master. As data scientists, we have the opportunity not just to participate in the transformation of data science into a profession, we have a chance to lead it. We have a chance to be the leaders in driving data science into profession. So I talked about the power of economics. Every data scientist who wants to help and lead data science into profession needs to understand the economic value of data and analytics. It's a must. We need to start talking the language of the business. But I'm going to also challenge you here too around a concept around design thinking. I think data science, in order to make that transition from competencies, tools, and technology outputs to to outcomes, business and operation outcomes, you need to embrace design thinking. Let me explain to you why. Okay, first off, we know that data science is about identifying variables and metrics that might be better predictors of performance. And how do we transition the organization from asking questions about what happened to predicting what's likely to happen so they can make take prescriptive actions? Right? We know that's the heart. And we know we have this iterative process. This scientific method is based on rapid exploration, rapid testing, lots of failing. We try lots of different things to see what actually helps us to come up with a model that's good enough for the problem we're trying to solve. And the heart of this process is how well we define the hypothesis up front. If we don't spend enough time up front really understanding the problem we're trying to solve, the metrics and KPIs against which you're going to measure success, the stakeholders who are involved, the asset models we need to build analytics around, the decisions we're trying to make, the predictions we need to make, and the cost of the false positive and false negatives, this iterative process here is unbounded. We never know when good enough is good enough. We never know when to stop this process if we've not defined those things first. And in order to define the hypothesis thoroughly, that's not a job a data scientist can do. It's a job we have to do in collaboration with our business stakeholders, which is why we teach our business stakeholders and our data scientists the art of thinking like a data scientist. Yes, it's critical for us that we get the business stakeholders to understand how to think like a data scientist, how to embrace a rapid exploration, rapid testing, failure empowering, continuous learning scientific method. We need to teach our business stakeholders how to think like that so they can collaborate with us, provide the value of things that we need. This is where design thinking comes in. Design thinking is about speaking the language of your customer. It forces us as data scientists to stop being so nerdy on the technology, which is great, right? The things we can do with neural networks and reinforcement learning, it's absolutely stunningly great. But it's like making a dog walk on its hind legs. It's impressive, but for what basis? Design thinking allows the data scientist to really start to understand the language of the customer and how they see the creation of value. There's a well-defined process laid out, empathize, define, ideate, and prototype, right? And there's all kinds of tools that we can use, customer journey maps and personas and service design templates. There's all kinds of tools that we can do this. But here's the real gotcha. This is the really exciting part about welding data science and design thinking together, is because guess what? They look like different sides of the same coin. The process we go through for design thinking is very similar to the process a data science team goes through with machine learning. Analyze, synthesize, ideate, tuning, and validate maps very closely to empathize, define, and ideate, prototype, and test. One of them is human learning centric. And the other one is machine learning centric. But design thinking and machine learning, they actually blend together very powerfully. I challenge you as data scientists to expand your thinking beyond just the machine learning, deep learning, reinforcement learning capabilities, and start thinking about how do I integrate design thinking into that process so that I can understand and speak the language of my customers, understand from my customer's perspective the sources of value creation as well as the impediments to value creation. It's a true game changer. And while this is powerful, for us, it really manifests itself, and this is something we developed, we call the hypothesis development canvas. We use this is a design thinking fueled technique, and we use that thinking like a data scientist process to engage with our business stakeholders and create a hypothesis development canvas before we ever put science to the data. That's really critical. Think about all the things here, like the hypothesis. What are we trying to prove? What's the value of that? What are the impediments to the business from doing that? What are the KPIs and metrics against which we're going to measure success? Who are the stakeholders who need to be involved, and what decisions are they trying to drive, and what predictions do I need to make? And don't forget about panel number 12 here, the risks associated with false positives and false negatives. If you don't understand the cost of the false positives and the false negatives, then you will never know as a data scientist whether your model is good enough or not. You'll never know until you understand the cost of the model being wrong. And I'll tell you right now, it's not the data scientists who can tell you what the cost of the false positive and false negatives are. It's the business stakeholders. We have to create this collaborative environment using something like the art of thinking like a data scientist, and look to bring together not just the business and the data science and IT organization, but to bring together the entire organization, to embrace diversity of perspectives, that we can come in and figure out how across all these different perspectives can we build a model that optimizes across all these different KPIs. That's the challenge for AI. And this is what a hypothesis development canvas, when you embrace design thinking, can help us get to. All right, let me kind of wrap up on some new concepts here, some new topics. You're a guinea pig for some work I'm doing on this data monetization roadmap. I've been spending a lot of time recently talking to organizations, and most of them are not monetizing their data. And so I've done some research, and I want to share with you some thoughts on this. So the challenge has been is that most organizations today are still in stage one. They think that data is a cost to be minimized. They think data is the exhaust of the operational systems. They don't realize that data is the business, right? They think data is an outcome, an exhaust of the business. And for more and more organizations, data is becoming the business. In knowledge-based industries, data becomes the business. And more, every industry is becoming knowledge-based. But there's a phase two here. Now, in phase two, organizations start to explore the data monetization. They have small little proof of values. They have pilot projects. They start getting their feet wet, and they start seeing success. And when they have success, they move into stage three, where they start trying to realize more and more of that. And then they get to stage four, where the fact that the economic multiplier effect, the fact that my data and analytics, they never wear out, they never deplete, they can use across an unlimited number of use cases. And in the case of analytics, I can actually engineer analytics that are continuously learning and adapting. I can create analytic assets that actually get more valuable over time. That's stage four. So there's a couple of inflection points here that we as data scientists need to be aware of, so we can help our business stakeholders get over those inflection points. Inflection point number one is, how do we connect to and envision value? This is really about how do we get customers, our stakeholders, excited about the potential of data and analytics to drive the business. We got to get them started. And this is not about throwing technology at them. There's nobody you're going to talk to here who cares that you're using TensorFlow, who cares that you're using Python. They don't care. They got a problem. Maybe it's customer attribution or retention. Maybe it's new product launches, whatever it might be. They've got business problems and they want your help to solve them. So how do you help them to connect to and envision value? Understand what's important to them. Here's an example of the Starbucks annual report. If you want to understand what's important to your customer, understand what they're trying to do in the business side. And if you read the annual report, page 7, for example, they talk about the power of providing each customer the unique Starbucks experience to build upon a superior customer service and seamless digital experience in their annual report. If you're trying to figure out what's important to Starbucks, if Starbucks is the company you work for, or customer or company you're trying to service, take a look and you say, wow, this is important. This is so important to them. They mentioned the annual report. So what we have is and we teach this in our class, we have a tool called the Big Data Strategy document. And it's based on a very simple hypothesis. Organizations don't need a big data strategy. They need a business strategy that incorporates big data. And so if you take a look at this Big Data Strategy document, and by the way, you will get the slides, and these are kind of eye charts. I've got a big screen here, so not so much an eye chart for me. But what it does, it takes the business strategy, provide a unique Starbucks customer experience. It starts to break it down into its use cases, its desired outcomes, the critical success for the analytics you're going to need, and the data sources. This is not something that the data scientists can do by themselves, but it's a vehicle, a framework around which you can start having a conversation with those organizations who are trying to figure out where and how do I leverage data and analytics. Maybe we're at that first inflection point here, right? We're here. We're trying to figure out how we get people started. And you want to find that person in the organization, that executive says, I can do better. I know data and analytics can help me. Can you help me figure out where I should do that? The annual report is a great place to start. You talk to them, you ask the business executive, what's important to you? And then you work with them to create the Big Data Strategy document. Now you got something around which you can work. You've got the use cases around which you can go after. You start to understand the analytics you need to be. And more importantly, maybe the most important thing is you can understand the desired outcomes you need to start to drive. But there's now a second inflection point. So what happens here is once you get past that first inflection point, once people start seeing you having success around data and analytics, what happens is a rush. Every organization wants this. And it requires a very tight governance process, because what happens here is if we don't carefully manage that, govern that process, bad things happen, right? We get data silos and we get orphaned analytics. And the way that can help us to address this is around the creation of a data lake or a cloud data warehouse or cloud data lake, whatever you call your repository, or the transformation of that data lake into a data monetization platform. It's a platform around which I'm going to capture, drive the reuse and the continuous refinement of the organization's data and analytic assets. And in particular, the reason why I want to do this, the great destroyers of the economic multiplier effect for data are data silos and orphaned analytics. Data silos exist because you've got data stored in certain places that can't or won't be shared. That if you can't share the data, you can't realize that economic multiplier effect. And orphan analytics start from the fact that we build these one-off analytic models to solve a one-off problem, but they're never engineered to be reused over and over again. And if I can't reuse them, if I can't architect and engineer them in a way that they can be reused, then I can't get that continuous refinement, that continuous learning and adapting sort of thing. And this all revolves around Schmarzo, the famous Schmarzo economic digital asset theory valuation theorem. This is a theorem that says and talks about the power, the economic power of data and analytics when you approach the problem on a use case by use case, ROI driven perspective. What happens here is that there's three key effects, two that are pretty common, and the third one's kind of unusual. The first one is if I can get rid of data silos, if I can get rid of orphan analytics, if I can drive the reuse of my curated data and my analytic assets over time on a use case by use case basis, I'm going to reduce marginal costs. Why? All the data I need is there. Maybe all the analytics I need are there. I'm just recompiling them, reconnecting them like Lego blocks to solve the next use case. The second effect is because I'm reusing the data and analytics on a use case by use case basis, the time to value and the risk of doing the next use case has been reduced, right? I can shrink time to value. I can do the use cases faster and faster because I'm reusing, and I can de-risk the projects because I'm not having to build things brand new. I'm using things that are already proven out. But effect number three is the gotcha. This is that I can take digital assets like data and analytics. If I govern them correctly, if I engineer them correctly, if I curate them correctly, they can continuously refine and get better. So use case by use case, these are getting better and smarter. And what happens over time is any improvements in the data and in the analytic assets, any improvements that happens ripples back to every other use case. And you see this asymptotic explosion of value that occurs when you can drive this. This is the underpinning concept behind why Tesla's full service driving autonomous car is so powerful, because that car is continuously learning and adapting every time it drives, every mile it goes across 1 million cars. Anything that one car learns one day, every other car has learned the next day. The power of that is staggering. And maybe if I get enough people to buy off and believe it, maybe I can have a bling of some of a Nobel Prize hanging around my chest here. So let me wrap up here. I'll take some time for Q&A. As a profession, we need to transition from capabilities, technologies, competencies, and start embracing the idea that we can focus on delivering business and operational outcomes to deliver value. By the way, value isn't just financial value. I would argue that financial value is a lag indicator, but the lead indicators are around customer and operations and society, environment, other sort of things. Excuse me. But when we focus on understanding thoroughly, using things like the big data strategy document to understand the outcomes we're trying to drive, now I can re-engineer, I can backprop, wrong term, right? I can determine what outputs I'm going to need to drive those outcomes, right? I'm going to understand what data, what analytics, what tools, what techniques, right? Now I can understand how to drive those outputs. And by the way, the other part of this, using things like design thinking, is it allows me to drive the adoption and alignment around the analytics. Can't tell you how many data science projects I've seen where data scientists have developed an amazing model, so powerful that doesn't get used. And why is that? Because we never considered behavior and organizational alignment and adoption up front. We never drove the necessary change required to take an organization that's used to making decisions based on gut and some meaningless reports to start making decisions based on very granular, very predictive, very prescriptive analytic insights. So with that, do we have some time for some Q&A?
Yes, there are a few questions that have been asked in the chat box and the Q&A tab. So
can you read them to me?
Yes. So Sarthak asks, what is the role of TensorFlow in data science?
Very, very, very powerful tool. I mean, it's probably the machine learning framework of choice for most organizations. And you, as a data scientist, you need to understand TensorFlow. But let me tell you this. You don't necessarily need to learn TensorFlow as much as you need to learn how to learn TensorFlow. And what I mean by that is that tools are going to come and go. We're seeing an avalanche of tools, especially a lot of phenomenal open source tools. Don't bet your career on a tool. Learn how to learn a tool so that when the next great thing, so right now TensorFlow is the hot thing, but 2 years from now, will it still be the hot thing? Who knows? Who knows? So be prepared to learn new things, which, by the way, also means you need to be prepared at times to unlearn, which is the hardest thing for people to do. Humans suck at unlearning, but sometimes you have to unlearn things that you've learned in the past in order that you can learn new things. So yes, TensorFlow is important, understand it, but learn how to learn TensorFlow versus just learning TensorFlow.
Yeah, I think that's a very important point. Another question by Kaustubh is, will in the future companies shift over cloud in place of traditional one? I mean, he's asking if from traditional data sets will be moved to cloud.
Yeah, so that's a really interesting, a lot of debate about where should your data reside. I think my recommendation on whether the data resides in the cloud, on-premise, or some sort of hybrid environment, to me, I look at what decisions am I trying to drive and what's the latency of that decision. If I'm making decisions, if I'm creating scores on my customers on a weekly basis, that can probably sit in the cloud, right? But if I'm at the edge, an IoT edge, and I need to make real-time decisions, what's going on in the factory or in a plant or in an oil well, right? That data, I probably want to have that on-prem so I can make very rapid decisions and fine-tune and optimize the performance. So to me, I always use decisions as the vehicle, and the latency of the decision of when I need to make that decision as a determinant. Do I put it there on the prem or do I put it in the cloud?
Okay. Yeah. Yeah, I think that's also a very important point. The decision of making an on-prem versus cloud depends a lot on the kind of trade-offs that you are willing to have.
Yeah, let me give you an example. If I'm driving an autonomous car, I don't want that car sending its data to the cloud to figure out I should make a right turn or not.
Yeah, that
by the time it gets the answer, by the time the answer comes back down, I've already T-boned the car ahead of me.
Yes. So Matthias asks if he can add you on LinkedIn.
Oh, of course. In fact, everybody, you should get involved on LinkedIn, Twitter also. But there are marvelous, insightful conversations and debates and discussions happening on LinkedIn. You don't necessarily need to participate, but you should be aware. And by the way, feel free to participate. I know some people are scared to sort of share their thought because they're maybe new to it. But what you're going to find on a lot of the LinkedIn conversations is that we are all building on each other. We're all standing on each other's shoulders, and you might have a perspective. You might say, well, I was on a project and I noticed this. That sends off a whole stream of conversation. So darn it, get involved on social media, get into LinkedIn. And yes, you can watch the conversations, follow me and follow a lot of the people I follow, like Kirk Bourne and Ronald Van Loon and Doug Looney and those kind of folks. You will learn a ton because here's the real fact about the digital age. It takes about 6 to 9 months to write a book. It takes about 6 to 9 days to write a blog and have a full-fledged conversation around a topic.
Yeah.
So yeah, get involved.
Yeah. I've just added your LinkedIn link into the comment section. So if anybody wants to follow Bill, you can definitely follow him on LinkedIn. I think Kaustubh has asked a follow-up question on the cloud question.
Sure.
Yeah, his question is, will it affect the data security in the future?
Yeah, so then there's a topic I got to be real honest with you. I'm not much of an expert on. It does certainly seem that putting data into the cloud seems to be riskier. I've been told by many organizations that I need to unlearn my old biases and embrace new ones. I don't know is my answer there. There are people who are smarter about, by the way, that's a great question to pose on LinkedIn and to see if people have any perspectives on what are the security concerns with data being in the cloud. Again, there's some data you just may not ever want to put up there. Maybe your financial data, but we put customer data up there all the time, and it's full of PII, so personal identifiable information. So, man, that's a tough question that I'm sorry I don't have the answer to.
Yeah, I think the answer probably to it, and I am also guessing, is all of these trade-offs have to be made. So like depending on the computation power, do you need it fast, do you need it slow, the data security, and depending on these trade-offs, you make decisions and you kind of make a decision on this thing. So from what I have heard is there's a lot of hybrid modeling that people they use a hybrid model where some of the data which they need is this thing, and then there are newer platforms coming on which let you access whichever is hybrid and traditional together on one set in one interface.
Certainly hybrid seems to be the preferred option. Yes. And like I said, there's a lot of trade-offs, but that gives organizations the ability to manipulate, to move between environments based on if their situation changes.
Yes. I think we can take one last question.
Sure.
By the way, Kaustubh says he will definitely put it on LinkedIn. One last question is this question is related to the presentation of the data analysis. So she's asking, how do you present to the end users the new analytics, the data science 2.0 that is developed for the businesses?
So one of the most powerful tools in this space is mockups. I don't tend to present models or even the analytic outputs of my models. What I do is I create mockups, and you can do mockups on pieces of paper. I actually do most of mine. I code in PowerPoint, and you can show how the analytic outputs can be used to help drive business outcomes through mockups. So maybe it's a simple, a mockup of a mobile app that shows a technician what kind of information they're going to get in order to do the sort of maintenance. It might be, I'm working for a company right now called Scipio, and we're working in the fitness space, and we deliver analytics insights about what customers are most likely to attrite. And we have it on a dashboard, all the customers who are likely to attrite, what their score is, and right there you can take an action, what you want to do to try to save that customer. So think about the power of mockups, and they don't need to be fancy. This is one of the concepts behind design thinking I find so powerful. You can create mockups using Post-it notes and sheets of paper with customers that are really powerful in helping to confirm and validate exactly what it is they're trying to do with those insights.
Yes. Okay. So I think those were all the questions. That's the end of the session as well. Bill, it was a wonderful session to close off day one. I'm very sure everybody loved one. I found it super interesting. I hope you had a good time. I hope that attendees can connect with you in the lounge area or in the LinkedIn or through various mediums. And if they want to ask further questions, take more inspiration from you, I'm sure they will be willing to participate. From the comment section, everybody is saying that it was a very insightful session and they have had a great time. So thank you so much for taking out your time.
Thank you. Thanks for inviting me, everybody.
Yes.
Have a good time.
Yes.
Enjoy the rest of the event.
Yes. So with this, we come to the end of day one, everybody. A big thank you to all of our speakers and a big thank you to all of our attendees too. Hope you guys had a great fun. You got to learn a lot of new things, interact with the best of the best professionals and practitioners in the data science industry. We have one more day of Skillup, which is tomorrow. You will have 2 workshops and 2 working sessions scheduled. So hope to see you guys there. With that note, I say goodbye and have a good evening. Thank you so much.